Hello, and welcome to Section 4, Turning Configuration into Code with Docker Compose. In this section, we will discuss the importance of configuration as code, and we will learn how to create compose files to spin up multiple services at once. In this video, we will learn why configuration as code is so important and critical to DevOps. What is configuration? Configuration is the arrangement or setup of your system. When people talk about configuration, it can mean a wide variety of things depending on the tools that you're using. Configuration could mean runtime environment variables that are passed into your API. It could mean the number of servers that are running on your backend. It could mean, what ports are exposed on your Docker containers, all those kinds of things. Typically, though, the important part of this is that configuration is something that can change. It can be variable depending on where your system is running, and it defines what your system looks like and how it behaves. Now, many of these things you could set up manually every time they need to be changed. You could manually access your system and make those changes, but this comes with a lot of downsides, which we'll talk about now. The first downside to doing configuration manually is that you don't have backups or redundancy inherently. You could do backups of your configuration manually and set that up, but it's really tedious, it's really difficult, and there's a lot of room to make mistakes. So let's say you get a system running 5 copies of your application, and you manually changed a few settings in each one. If the computer running those applications broke, and you needed to recreate the whole system on a different computer, you'd have to do the whole thing from memory, unless you happen to document it somewhere. And even if you did document it, you'd still have to go make all of those changes one by one manually. The next downside to manual configuration is that it's not version controlled. If you're making a change on a server, you're actually just going to have to access that server and make a change. And there's not a great way to track changes to the configuration or who made those changes and when those changes were made. If you need to roll back to a previous version, there's not a great way to do that either. The next downside is difficult onboarding and discovery. It's not easy for new team members to figure out what the system looks like without having somebody else sit down and explain the whole thing to them. If they want to get up and going, it's hard to remember exactly which ports need to be exposed, what the name of the application is, what volumes need to be mounted, etc. It's a lot easier for them to discover a single file that contains the entire state of everything they need to know, and they don't need to go recreate it manually. It's a lot better to bring on new team members this way. Another big downside is it's a lot easier to make typos and mistakes. Because these things can't be reviewed in a peer review if you submit a PR when you make changes that are stored in version control, it's easy to make simple mistakes in commands that can have really big impacts. Even big companies such as AWS have had entire regions go offline because they forgot a comma or forgot to include a flag on a command that they were running in the terminal. It's a lot better to be able to store your changes in version control and get other people to review them. A command that they were running in the terminal as code benefits. Instead of doing everything that I just mentioned, you can store the configuration, since it is code, in your version control system. You can track the changes to it, see who made changes. You can back up your configuration, and any new team members, if they're digging through your code, they will discover the configuration and fully understand what the system looks like without having to ask somebody else or dig through servers or have access to systems in order to determine what the configuration is. Additionally, because your configuration is code, this allows you to have one of the biggest benefits, automation. Again, we're coming back to this exact diagram, and remember that automation is kind of the key to DevOps. So if your configuration exists as code, there are chances that there are already tools that exist that can automate the changes to all steps of your system. So Docker is really focused kind of on the packaging step of this loop, and helps with the release by providing a really nicely bundled package. Configuration as code helps you with the configure part, and if your config is code and you have automation in place, this entire step of package, release, and configure can all be done automatically. You don't have to do any manual steps. Every time you make a change and put it into source control, everything is done for you, and that is huge. That is key for DevOps. So how does this relate exactly to Docker Compose? Docker Compose enables you to store your Docker configuration as code. So instead of remembering to type our Docker run commands, like you see on the left, in the right order with the right parameters, you can instead store the state of your system in a YAML or JSON file and let Docker Compose create everything for us. So instead of typing everything on the left every single time, you store everything on the right in one file, And when you want to spin up a stack, you just type docker compose up, and then it's done. It's up and it's created. And if you want to change the port of a system and you need somebody else to review your changes, you just go make a change here on line 8 and change port 3000 to port 3001. And then you save that, you check it into your source control, and somebody else can review that change without having to have both of you SSH into a server and make your changes manually. And you can track in the history of your Git tree or whatever source control you're using, you can track the changes that have been made to your source control.